Good morning, everyone. Thank you so much for joining us on this Thursday morning. Hopefully you are in the right place. You're joining us today for a joint webinar on Okta and Varonis and how well they can work together in their interoperability. I'm really pleased to be joined by the wonderful James Dawson today, who is the Cloud Security SME subject matter expert for Varonis. James, do you want to give a brief intro?
Sure, thanks very much, Grace. So yeah, I work as part of the cloud security team at Varonis. So this team has sort of a real focus on helping organizations secure some of their cloud applications, applications like Okta, Salesforce, Google, AWS. Thanks, Grace.
Thanks so much, James. And if we haven't had the pleasure of meeting before, thank you so much for joining us today. And it's wonderful to meet you, albeit virtually. My name is Grace Maher, and I head up our support and our pre-sales teams over here at Somerford Associates. Somerford are a premium partner of both Okta and Varonis, and we're really pleased and proud to show the interoperability here today for both of them. Thanks so much. So just to really briefly give you a little bit of an overview of the two technologies, just so that we understand, some of you on today may be already working with Okta or Varonis, or maybe you are just introducing yourself to both, but really just wanted to make sure that you have a good kind of introduction into both of them here before we start obviously using them together. Now, Okta is, of course, a cloud-based identity and authorization platform. Now, what we're seeing inside of businesses today, and of course the pandemic has accelerated this, is there's a lot of digital transformation happening, a lot of migrations to cloud, a lot of new services and new applications being used for remote access, home working, and companies are still carrying a really heavy burden in terms of legacy infrastructure that they're kind of piecing together to make things work, Well, nobody could have foreseen this or expected us to go from maybe a few centralized office buildings to hundreds dotted around the country, from our kitchen tables, dining room tables, offices, if you're lucky enough to have one. Now, of course, there are a whole host of different ways of authenticating and managing identity within all of these different applications, infrastructure, and identity stores. And this could be something like Active Directory or LDAP. It might be using Radius, you might be using provisioning or ADFS, or maybe you're using kind of a WAM or something like that to access all of those web apps. Now, from a customer side of things, if you do have customers, whether those are customers internally, other services or departments that use your services, or whether that's a customer actually kind of external to you, it can also then fragment their identity across all of the different services you offer, the different applications, websites, portals, and even IoT things that they may have access to. And this creates a real massive administrative burden and also, of course, a huge security risk to thousands of organizations today. So we address every identity use case, whether we're talking about your workforce identity, so your colleagues that I was going to say sit beside day in, day out, sit on Zoom too day in, day out, whether that's your customers external or whether that's your customers internal, such as partners or vendors that you work with. Of course, there are different applications that they may need access to, and those might be on-premise, they might be cloud, or they may even be hybrid. Of course, your workforce, you might want to give them access to different pieces of infrastructure, whether that's cloud infrastructure, AWS, GCP, or Azure, or of course, if you've got more on-prem infrastructure, like you've still got some Oracle DBs hanging around, or you've still got some on-premise servers or infrastructure there. And of course, if you are making use of APIs, securing access to them on a private level and also public APIs you may have open is a real concern and actually quite difficult to administrate in a centralized way. So Okta is the world's most secure and reliable identity platform. We have the largest integration network with well over 6,500 integrations now. I think we're nearing more like 8,000 now. Now, these integrations are pre-created applications that you can literally plug into and then put the information in for your specific location of that app. And then it will go ahead and do all of the kind of logic around authenticating and have everything configured for you in a really easy to use way, all within a UI. This allows you to deploy in literally minutes rather than hours. And when I say minutes, we've literally deployed Okta for organizations in 2 hours. So it's a very, very fast, reliable, and secure way to centralize your identity and do it in a very nice and easy to use way for your admins as well. Being one myself, I have them close to my heart. Now, what can we do within all of these integrations? Well, of course, across your workforce and your customer identity, we can do your standard SSO. And I think we're probably quite used to doing that, kind of logging into one centralized location and having all your apps there. Or maybe you have desktop SSO where, you just don't have to authenticate once you sign into your workstation. Of course, all of that can be done within Okta. And of course, then we're centralizing all of those different application accounts, end user accounts, Active Directory accounts, Salesforce, all of the different applications day to day into one singular identity for that person with all of their different profiles underneath. So really, really nice and easy way to manage that. Of course, we have our amazing adaptive MFA, which allows you to do policy-based MFA elevation, step-up authentication. And we can also do loads of different types of MFA as well. So things like a soft token through Google Authenticator or our Okta Verify app. And Okta Verify is a fantastic app because it actually also makes use of the biometrics in the device. So if you have a fingerprint or Face ID on your phone, then you can go ahead and actually use that to then get access into your token. So again, securing yourself is something that you are physically yourself, or something that you have, in this case, your soft token. Now, with our lifecycle management, we can literally revolutionize your onboarding. And I say this so passionately because it's revolutionized our own. You can go from spending hours setting up an individual user to literally just 3 to 5 clicks and having everything created for you. It can do the automated creation of accounts, attribution of licensing, and then, of course, the change or update to that account. If that user moves up to, say, management, they'll get additional access, or maybe even if they move teams, access to additional applications to suit their new role. Of course, when somebody leaves the business, lifecycle management is a fantastic way to literally schedule a date that you would like for that user to go ahead and be deprovisioned. It will go ahead and do that for you and then send you a nice friendly email just to say, hey, just to let you know we've done this. And of course, you can also have additional reminders if there are any accounts that you have that are completely internal to you and you do want to just manually deprovision those yourself. Now, we control all of this lifecycle management through our universal directory. And this is what we spoke about earlier with regards to having a single profile or a single kind of overview of one user with all of their end accounts underneath it. What this does is it provides you a really clear view of where people have access into, but it can also help relieve any kind of support issues that you may have with access and people raising tickets for can't access this or I need to log into that. If they ever have a problem, it's very quick and easy to see why that's happened through the logs, but also either maybe they just don't have the application provisioned to them under that profile. And again, it's so quick and easy to be able to see that listed and also see, of course, all the attributes, say from Active Directory in there as well reflected. And you can use that to also control different things about their application end user accounts. So for example, you can use their OU to map to a group in Okta, which can then map to a group in that end user application. So a really great way of securing role-based access across all of your different credential stores in one centralized place. Now, OAG extends the ability to be able to have this universal directory and this kind of a grouped identity by leveraging this against physical access to remote servers, workstations, things like that, and actually also being able to replace your web access firewall if you do also have one of those. that's quite a legacy way of doing things nowadays, and obviously can create quite a lot of administrative burden. So OAG is a fantastic way to kind of replace that if you need to do things like header-based authentication, or if you have specific apps that maybe you offer out to partners or vendors. OAG is a fantastic way to secure the access to them and prevent access from any other way. Now, of course, we can also extend this kind of server-based authentication into your APIs. So if you do have any APIs that maybe you surface to customers or partners, you can secure them and also provide additional constraints, for example, things they can run and can't, and also throttling and thresholding to make sure that they never become kind of overused or not able to keep up with the number of requests coming through them. Now, ASA, Advanced Server Access, I'm throwing lots of letters around at you, so forgive me. But Advanced Server Access provides you access into those legacy systems and also those that maybe you want to provide access to, say, via VirtualBox or another kind of virtualized workstation software. It can really help you secure what level of access users are going to have to each individual server, but also then prevent things like access to, say, command line, or prevent them from running certain things on that server there, which can be a great way of restricting access to, again, maybe some of that legacy infrastructure that you do have hanging around. Now, of course, customer side, we can handle all of the user level management of all of those different attributes that a user may have as they move through your services and products. And of course, we can handle all of the authorization flows for different services, maybe applications, and any kind of reviews of maybe documents, things like that need to happen. Of course, we obviously can control that authentication piece as well and help customers authenticate into your products and services by using our SDKs and our APIs. And it's a fantastic way of actually providing customers a much more robust identity kind of platform and way of accessing your services without actually changing the flow in the way that they currently sign in today. And as I say, we are the industry's most secure and reliable. I always say we got more attestations than you can shake a stick at. SOC 2 Type 2, ISO 27001, 27018, HIPAA, FedRAMP, CSA Star, and I can't say any more without a breath. So when we say we are very trusted, we've kind of made sure that if you are putting all of your identity into a cloud platform, that you need to be able to trust and rely on that platform. We have an always-on architecture, and we also publish our uptime very openly online. So you can see in 15-minute increments if we've ever had any outages. I'm really pleased to say that for years now, since I've been working with Okta, there hasn't been, and touch wood, there wouldn't ever be again.
So what I'll do is also give a brief overview of Varonis, and then following that, we'll go into an attack scenario that involves both Okta and Varonis and how we can investigate it. So many of you on the webinar may have heard of Varonis. Varonis is a data security platform. What we really mean is that we protect the data in some of your most critical data stores within your environment. So that could be on premise or in the cloud. Maybe it's a file server or a bunch of SharePoint servers or a NAS array, or it's a cloud application that stores business critical data like Salesforce or AWS S3. We also monitor the infrastructure that supports all of this data. So that could be Active Directory, DNS servers, proxy servers, and VPNs, as well as authentication channels such as Okta. And with all this data, we'll pull out various different metrics to achieve some of the use cases that you see on the side around data protection, threat detection, and compliance. And that starts with the classification of content within these different data stores. So Varonis will be able to help you find the sensitive data wherever it exists. So this could be GDPR regulated data, this might be PCI DSS data, or it could be sensitive information specific to your business. On top of the content classification, we're also going to map all of the users and all of the groups across these different services and their relationships to the data. So the permissions that they have on the files and the folders on your file server, or the opportunities and accounts within Salesforce. So you can really understand why a user has access to a particular object, where that access comes from, and combining that with the content classification, whether that access is sensitive or not. And then on an ongoing basis, we're going to monitor the access activity to all of this data as well. So you can really understand how it's being used by your users. We can then layer on top telemetry from the perimeter and from authentication traffic, so that we can start to help identify where there might be threats threats upon this data. We can also help you proactively lock down the permissions and achieve the principle of least privilege to move towards that data protection use case. And combining those can help lead to improved compliance and the ability to prove compliance to a regulator. So in the cloud, there's some unique challenges that come with protecting this data. So at Varonis, we have support for some of the most critical cloud business applications like Slack and Salesforce, Jira, GitHub, and AWS. And compared to on-premise data, there's a few nuances that I think it's worth addressing in these different cloud applications. So one of the first challenges is the normalization of permissions across all of these different platforms. For each cloud service that you adopt, there's a unique permissions model to each of them. If it's AWS, you might have to use the concepts of policies that are applied at different levels to your users and to roles. With something like Salesforce, they have profiles and permission sets that can be layered on top of each other to assign access to objects and rights within the application. And when your business starts to adopt all of these different cloud applications, it can become incredibly complex to try and manage all of these permissions and to try and understand where data is, or where access is coming from. So with DatAdvantage Cloud, one of the things we'll do is this complete mapping of the users to the data, but then also normalizing that level of access and using this CRUDS acronym that you see on the right-hand side, which stands for create, read, update, delete, and share. It means that from a user level, you don't need to have a detailed understanding of permissions on whatever application we're looking at. You can quickly deem from the tool that Judy at the top there has read access on the roadmap XLS file. However, John below her has a higher level of access of create, read, and update. And this can be done without having to really understand the unique permissions model for whatever application we're looking at. And with this whole mapping of permissions, we can then start to have a really proactive security approach to locking down data in the cloud. So you can understand where the sensitive data sits in these cloud applications, where the user's access is also coming from, and then what they're doing with it as well. And that leads me on to the second component and the second challenge of monitoring some of these cloud applications, which involves the audit trail. So for each of these different cloud applications that you may adopt, there's a different level of auditing that's exposed. And again, like the permissions models, there's also syntax and different level of detail that the cloud provider will offer or expose to the customer. So what we do with DatAdvantage Cloud is pull in audit logs from all of these different places. So that's the authentication logs, that's the administration activity that happens within the application, and also the access activity to the data as well. And all of these are normalized, and they're also enriched as well. So you can get a higher level of detail than what you'd be able to get natively with the cloud application. And this enrichment is really key when we come on to the threat detection component. And this is what I'm going to focus on today when we go through an attack scenario. So in DatAdvantage Cloud, we're pulling in all of these events from all these different cloud services. There's the initial authentication event, and then the access event, and any changes that may happen within the cloud application. And they're then applied against policies that are built into the tool to alert when there's suspicious behavior within the cloud application or across different cloud applications. And we have to then bring all of this together by connecting all of these different cross-cloud identities. Something like Okta really helps manage the access to all of these different applications, and it can sort of tie together this single human user with all of these different unique applications that have their own account stores. And it's the same with DatAdvantage Cloud. So using that kind of mapping with Okta, we can also pull together all of these different applications into this single human identity that can make an investigation into a user like Alan Carey significantly faster than having to jump between each of these different unique services. Some other things to mention about the DatAdvantage Cloud platform. This is a completely cloud-hosted SaaS offering from Varonis, so there's no infrastructure to manage, there's no servers to stand up. The data collection is done via the native APIs for each of these services. So there's no proxy that needs to sit in line to capture the traffic between your users and each service. And the tool itself then comes with a huge number of these built-in alert policies, but also the ability to make custom policies as well. So you can detect all manner of different threats across these cloud applications. So what I'd like to do today is go through an attack flow that begins with Okta and ends up compromising some of these business critical cloud applications, so specifically Google Workspace and Box. And we'll look at how Okta kind of detected some of these components and also how Varonis would detect this as well. So we're going to start with an initial intrusion phase, and this is going to begin with a phishing email. So we're going to be targeting an Okta admin. And this is one of the most critical identities within a business, as they really have the keys to the kingdom. What we're going to be able to do is hijack this user session, get into the Okta admin console. From there, we're then going to have access to a large number of services, and we're going to start to do some reconnaissance, access services like Google Workspace, and try and pull out some valuable data, as well as some company files as well. And then, as our Okta admin, we're going to pivot into Box. We're going to make some changes to some sharing settings, and expose a folder via a public URL. And this will establish some persistency to this data. So even when this Okta admin changes their password or the session expires, we'll still be able to access that data inside Box. And throughout this, we'll take a look at how each of these different stages can be detected and potentially stopped. So let's start with a focus on our initial intrusion phase. So we're going to have our victim who will receive a phishing email. This is going to be quite a well-disguised phishing email. They're going to click on a link, and it's going to take them to a phishing page for Okta. So this isn't going to be the legitimate Okta logon page. It's going to be a fake page where they're going to enter their username and their password. And this is going to be proxied through the attacker's machine. So this is where the attacker can then pick up the clear text username and password for this user. The attacker's machine is then going to pass this username and password onto the legitimate Okta authentication service. That's then going to request a second factor to this authentication. So that could be a push notification, it could be an SMS. It doesn't really matter the method of MFA. It gets sent back to the user. The user then passes that back via the attacker machine to the Okta authentication service, which passes back a session token to the user, which is going to be picked up by the attacker's machine. So this pickup of the session token, the authentication session token from Okta, is where the attacker is able to then bypass MFA and get into this admin's dashboard for Okta. It's worth mentioning that this technique can be used to compromise basically any service that uses MFA. I've seen this used on GitHub before. I've seen this used on Office 365. This is just, a component of MFA and phishing that users need to be aware of. So let's see this attack in action. So on the right-hand side, there's our victim, and on the left-hand side, there's our attacker. So our attacker is crafting a phishing email here. So they've set up a lure with a tool called Evil Jinx 2. And Evil Jinx is this framework that allows us to that allows the attacker to build these links to these phishing pages that proxy the connection back through their own server. So they've just sent off this phishing email to our victim. So hopefully Jerome on the right-hand side will receive this in a minute. And there we go. So there's a few components where the victim could have picked up that this isn't legitimate. They could have looked at the email address on the email itself, or maybe some email security would have protected them here, or they could have looked at the URL at the top there on their Okta logon page, which isn't the legitimate Okta logon page, and also isn't using SSO. So they've put in their username and they've put in their password, and then it's requested a second two-factor authentication, which they put in the code. This was all captured by our attacker on the left-hand side. So now what they can do is just run these commands to pull up any of the sessions that have been captured. In this case, we've got the James Boynton email address and password. And we've also got this JSON text here, which is the authentication session cookie for this Okta logon. So now on the attacker side, it's as easy as them importing the unique ID from this authentication session into their browser. They can then refresh the page and it will log them in. And this is a key component of the attack and why it's so critical to be aware of phishing emails, be very conscious of spoofed sites, and really have a well-trained staff who are capable of looking out for this kind of thing. So we're now on the attacker's machine here, and we're logged in to the dashboard for Jay Boynton that you can see at the top there, who is our Okta admin for this organization. So now we're inside. Now we're inside Okta. We can start exploring and seeing what Jerome has access to. So we've got his Okta applications dashboard. We can see there's things like Google here, which is going to store some of the most critical data for the organization. Because Jerome is also an admin for Google, he has access to the Google admin page. So he could start adding some new users. He could change email addresses, change passwords. He's going to do a bit of reconnaissance here and download a list of users. This might be useful in further phishing attacks later. And we can start doing some research on these names to try and identify some of the executives within the organization. And just to skip a few steps here, Catherine Abner is one of these executives. We could have found this information from maybe the company website or from LinkedIn. But using this name now, it seems like this would probably be a good person to target. And one of the ways we can do this is by going to Jerome Boynton's application assignments within Okta and make some setting changes, asking the user to this user of Catherine Abner. By doing this, what we're going to do is now log in Catherine's Google account as opposed to Jerome's own. And as this is an executive within the organization, there's likely some valuable information that's part of this. So let's take a look at the attack so far and maybe just summarize what we've done to this point. So we started with this initial foothold into Okta. So this began with a phishing email that was sent from the attacker to the victim, Jerome Boynton. Jerome fell for this phishing attack, and we were able to then bypass MFA and get into Okta. The attacker was then able to do some reconnaissance because they were also a Google admin. They could download this list of users from Google, do a bit of research offline, discover an executive within the organization, and then use some of these settings within Okta to impersonate this user. So on the Varonis side, there's a few things that we might have flagged up here as being suspicious. I'm expecting that I may see some triggers on threat models for activity coming from a new geolocation. It's highly likely, but to us, it's guaranteed that the initial log or authentication into Okta from the attacker's side came from a new IP, potentially came from a different country. So we might see an alert for activity from that new location. Potentially the IP they're coming from might have been flagged up before. There might be some third-party threat intel that's discovered that this is a known malicious IP. So we may see an alert for that. And then we also might see alerts for some of this unusual administrative activity that's happening within the services. So on the Google side, we might see some alerts for this this download of the user list, and within Okta, this new application being assigned directly might flag up as suspicious. And you can see a screenshot of that on the right-hand side. I'll go into my lab environment and we can investigate some of these alerts for real after I've gone through the attack. But first, I'm going to let Grace talk a little bit about some of the alerts that we might have seen on the Okta side.
Thanks so much, James. It's been a little bit scary to watch this, even though I know it's a video, but it's all good learning. So just wanted to show a few of the different events that we would see. And I actually took this from a production tenant, hence me just removing some stuff. But I actually wanted to show you some examples of where you can see there's verification failures, where there's token requests that are coming up a little bit strange, and then also trying attempted sign-ins from invalid credentials here. And you can also see examples of failed authenticator attempts. So what I wanted to show is actually, because this has all been picked up by Okta within its own reporting for anomalous login activity. So it's showing you here all of the different examples of when, you know, there's been somebody kind of attempting to sign in a way that's not expected. Now, a few of these have also been due to, you can see here, that there's verification failures, and these are what we normally tend to see when somebody is testing credentials. So if they've got access to, say, for example, that spreadsheet full of names and they're trying different ones in different formats, you might see examples of that. So for example, somebody testing out what the usernames might be by attempting initial with last name, first name dot last name, and then first name, you know, different variants like that. It's a really clear telltale sign of people trying to brute force access and trying to guess usernames. But here is clear examples of people just trying to sign in with invalid credentials. And also if they then use a token that has expired. So of course, all the soft tokens are time-based. If you were extremely lucky for while that hacker was proxying the session, if that token had just expired on your phone as he attempted, or they had attempted to put it in, then that would come up again as a failed Google Authenticator attempt. So just wanted to show some of the examples, and of course it displays this very different behavior than, say, Varonis. Varonis would categorize. But Okta is still picking up kind of anomalous activity here and reporting it. And of course, you could suck this into Varonis, or you could report on it into a SIEM or something like that as well, if you did want to.
Yeah, thanks, Grace. So let's continue with the attack. And this is where we'll really start to see some of that sort of post-authentication activity happen. So now the attackers logged into Google under the user Catherine Abner. So they're having a look at what Catherine Abner has access to. In this case, there's an HR folder here, which has some sensitive information inside it, so some salary information. And they're going to use some of the built-in collaboration capabilities within Google to share out this data. And that happened quite quickly there, but you might notice that they shared it out with a Gmail address that was Catherine one. So they've just created a fake account for this user and they've shared data to it. So this is going to try and, the reason they're doing this is that they're trying to on that folder, and it's nothing to watch. So let's jump into the next, or let's have a little review of this exfiltration piece in Google. So Jerome then logged into Google, impersonating Catherine Abner. They exported that list of users. They then performed some reconnaissance on Catherine's Catherine's Google Drive folder, found this HR folder and used some of the built-in sharing settings to start to share that data out. So we might see an alert at the top here. This Catherine Abner shared some sensitive documents with unsanctioned contractor users. So there's some of those components that I was talking about earlier that really come into play here. So there's this ongoing monitoring of the activity on all of these services. So there's the administration activity, like Jerome Boynton exporting users' details, but there's also the access activity to the data itself. And we're combining that access activity with the content classification. So DatAdvantage Cloud understands that this salary document is a sensitive document. It'll also be able to quantify why it's sensitive. So it'll be able to tell you that there's this many pieces of PII or UK regulated data inside this particular folder or this particular file. And then when there's an unusual access or a change in the sharing settings to that document, like a change in the ACL, it can then alert you to this kind of behavior. So if we jump back into the attacker side, Jerome is now back in, or the attacker as Jerome is now back inside Okta, and this time he's going into Box. So performing a bit of reconnaissance on what he can do inside Box. Another big collaboration tool. And you can see he's logged in here as himself, or as the victim, Jerome Boynton. But inside Box, we can also see the Box admin, so a user called T. Stanton, or Timothy Stanton. So coming back to Okta, what we can do is change this application assignment as we did in Google, refresh the page, and we'll be able to log into Box, this time as a Box admin. So now under Tim Stanton, we've got a lot more access here. So there's some sales folders that we have access to, there's some marketing folders. And what the attacker's trying to do here is share this data out. So similar to what they did in Google, they're trying to share it out. However, they're having an issue. They can only share it with invited people. And they want to share it, the sharing settings for this particular Box environment are quite locked down. But as they have access to this Box admin, they're able to come into the administration settings for Box. We see a link here to a folder, and only people inside this folder can access the link. But this time, what they're doing is setting up a custom URL, and they've changed the settings so that anyone in the link can access that particular folder. And we can then just verify this works by copying the link, pasting it into an incognito window, and ensuring that we have access. And this is the persistency that the attacker is establishing into this environment. So that session token that they had that has allowed them to log into Okta isn't going to last forever. Eventually, Okta will automatically log them out after it expires. So they're going to want to still have access to the data, and this is why using some of these built-in collaboration and sharing settings is so valuable. Even when their access to Okta disappears, they can still access this customer folder. As new customers are added, they're still going to have access to the confidential data inside it. So this was the final phase of our attack. This was exfiltration from Box. So the way that this happened was the attacker found Box's admin email address by going into a standard user for Box, so Jerome's Box user account. They then did that same impersonation that they did for Catherine Abner. So they impersonated the Box admin user, logged in under that user, and then they were able to share out some sensitive data by using this custom URL. So it makes it very easy to access, and anyone with the link can access it. So some of the threat models that you will potentially see triggered here are things like new geolocation activity and suspicious IP activity coming in. So again, this is all new activity happening within Box. But then also these files being shared out with a custom URL. So it might be potentially sensitive files or just suspicious activity, because this is something that the user Tim Stanton has never done before. So what I want to do is dive into the DatAdvantage Cloud interface, and we can take a look at some of these alerts and investigate them in a little bit more detail. So hopefully you can all now see my screen, which has got the browser window with DatAdvantage Cloud up. Grace, please let me know if it isn't showing. So this is the homepage for DatAdvantage Cloud. It's relatively self-explanatory. On the homepage, we've got some of our open alerts on the left-hand side. We've got a timeline of our activity across all of our different services that we're connected to that you see along the bottom here. So it includes things like Salesforce and AWS, Google, and Box, and Okta as well. In the middle, we've got some key risk indicators for our environment. So these are typically numbers that in peacetime, administrators and security professionals who are using this tool typically want to reduce down to a minimal amount. So this might be switching off external identities who have access to our resources who are no longer using it. So there may be a use case like a contractor who comes in to set up your Salesforce environment. They're provided with quite a high level of administrative access. And after the commissioning work is done, they then no longer require that access. But what we often see is that these kind of accounts are left open. And this is a big security risk and one of those key identities that should be locked down for every application that you have. What I want to do though is focus on the open alerts. So I'm going to go see all alerts, and we can drill into the alerts page for DatAdvantage Cloud. And we can see a flurry of activity that came in all around the same date of August the 10th. So if we start with that first bit of activity. So if you'll remember, the initial phase of the attack began with this phishing attack, where the attacker sent an email to our victim, the Okta admin, Jerome Boynton. And Jerome unfortunately fell for this phishing attack, and their session token was captured, and this allowed the attacker to log into Okta. So when that attacker logged into Okta by using that session token, this is when we would see our first alert within DatAdvantage Cloud. So we've got Jerome Boynton is connected from a suspicious country. So the user is connected from a country rarely used by the organization or by this user. And we've got a bit of a summary of what we see here. So a summary of the user Jerome. We've got some tags that are associated with him that we know are true. So Jerome Boynton is an internal user for this organization. And we also know that he is a privileged entity and an admin. We can see the session start action that happened here. And if we want, we can drill into these logs to look at a little bit more detail and look at some of the enrichment that we might see as part of these logs. So things including a classification of the IP, of the device, also if there was any sensitive data that was touched during this particular bit of activity. Because the attacker was trying to obfuscate their location, we did also see a connection coming in from a known Tor node. So there's some third-party threat intel that's part of DatAdvantage Cloud that allows us to identify suspicious IP addresses. And we saw this connection come in again for Jerome Boynton. Once we were logged in, we were then able to go into Jerome's Google account. So again, we're seeing more suspicious IP activity from Google, and then we're seeing this strange administrative activity coming from Jerome as well. So we saw a download of the user list. After the download of the user list, Jerome then went back into Okta and assigned the application to a user, or assigned to his user account the email address of Catherine Abner. And again, we'll be able to see all of this activity in the logs, and we can look in the more detailed logs here to see Catherine Abner's email address being assigned. But what we then can do, but we can also see this from this unexpected email address being added. So an additional alert that triggered here. The attacker was then able to log into Google under Catherine Abner. So we're seeing a successful login, again from a suspicious country, for our user of Catherine Abner. It's worth mentioning for any of these identities across any of our cloud platforms, we can drill into the identity itself and really look in detail as to what that user has been doing. So if I go into the identities page for Catherine Abner, this is really where we can start to see some enrichment coming in. So we've got the Google user of Catherine, they're inactive, they're internal, we see some metadata about their account. We can also see any countries that they typically operate from. So largely from Israel, but because of this attack, there's been a small bit of activity from Romania as well. We can also see a timeline of any activity from this user. So these are all of the access events that are happening, all of the authentication activity, the sharing settings that they're changing. We can also see any recent resources they're accessing. And one of the other things we can do is use this mapping that Varonis does between users and data to really understand what data a user has access to. So this isn't just what they've accessed, but what they're capable of accessing. The permissions that they're assigned, what does that give them access to? And you can see here, there's all of these different files and folders. Some of them are sensitive. We can see that there's 3 hits in the salary file that comes under our classification of security. We can see where there are public files that this user has access to, and we can see the level of permission that Catherine has across these files as well. So you can really start to get some context around the user or around the data that's been accessed. You can also flip this on its head, so you can do this bi-directional view as well. If I drill into this document of salary, I can see, first of all, where this document sits in a directory tree. I can see all the users who have access to this particular document. And I can also see a timeline of activity from this document as well. So on this entitlement side, we can see there's the original owner, Catherine Abner, but then there's also this external account that the attacker shared the data with. So there's catherineabner1@gmail.com, where they've got this ability to read, update, and share the file. And this is what the next, or some of the next alerts are about. So we're seeing this alert here for Catherine Abner sharing sensitive documents with unsanctioned users. So you get this alert as soon as it happens, but you'll also get this alert. You'll also be able to run a report to see where all of the sensitive data has been shared out with external users. So if you want to proactively go through the environment and clean this up, you'll be able to see that as well. And then just to close out the attack, we then saw Jerome come back into Box. There's a suspicious login from these different countries. We also then saw a new unexpected email address being assigned in Okta. So this is where Jerome, or the attacker, changed Jerome's email address for Timothy Stanton before logging into Box again. Suspicious geolocation alerts coming in, and finally this sales folder being shared out with a custom URL. So what you can see is combining Okta and DatAdvantage Cloud, you can see the whole, every step of the attack. And all of this could have been picked up. We could have been sending alerts out and including this as part of the sort of security and automation and orchestration tool so that we could stop the attack in its tracks. So what I want to do is just jump back and kind of summarize some of the integrations between DatAdvantage Cloud and Okta, and then we'll stop for some questions as well. So having DatAdvantage Cloud and Okta is a really fantastic pairing. Okta is the gold standard for single sign-on and authentication. You know, to let you in behind the doors, we use it heavily internally within Varonis. We think it's a fantastic tool. Obviously, Somerford also think it's a fantastic tool that every organization should be using. Combining Okta with Varonis can also then allow you to see an attack when it happens past that authentication stage. So Okta is providing that security from the single sign-on, from the enforcement of the MFA, from the policy and contextual enforcement of an authentication. If the user then does get in, you have that full audit trail of what a user did once they're inside an application that was assigned to them through Okta. And if there is an attack, you'll be able to investigate that in depth with the tool as well. With DatAdvantage Cloud, you can really start to clean up really start to clean up access across all of these applications as well. So on the Okta side, you can enforce this principle of least privilege in terms of access to the applications. With DatAdvantage Cloud, you can enforce the principle of least privilege in terms of access to the data within the application. You can also use DatAdvantage Cloud to verify the configurations within Okta. You can see where applications are being assigned from, where there's overlapping group assignments, where there might be potential offboarding gaps. And if you also, as Okta is such a gateway into all of your data, you can use DatAdvantage Cloud to provide enhanced monitoring of your Okta admins. So people like Jerome Boynton, so that you get alerted at very early stages if there's a potential misuse or compromise of their account. So thank you very much for listening to this webinar. Grace, I don't know if you have anything else to add. Otherwise, we can open up for any questions there may be.
No, nothing from my side. Just as you say, opening up for any questions that anybody on the webinar today might have, whether it's about Varonis or Okta specifically, or the interoperability between the two. Please pop them in the questions box there and we can answer them as they come in. Of course, if you do have any questions after today's session, I will go ahead and pop our email address in the chat box. So please do feel free if you are interested in a one-on-one demonstration, or you'd like to know a little bit more, or if you just have a gotcha question later on in the week and you want to pop it through, please do feel free. Okie dokie. If there's no questions, I'll go ahead and close us off now. Of course, if you do have any later on, please do feel free to pop them through to the email address that I've just popped in the chat box below. It's just info@somerfordassociates.com. Or of course, if you lose that, just feel free to pop it through on an inquiry form on our website. Or of course, I know Varonis have a fantastic ability to be able to chat with somebody on their website, so you can always use that function as well if you have any specific questions. James, any closing thoughts?
No, nothing from me. Just thank you very much for having me on.
No, it's our pleasure. Thank you so much for your time this morning. Thank you so much for everyone for joining. I hope that if you're a Varonis or a Okta customer, that you have learned a little bit more around the two, and of course the way that they can support each other. I hope you have a wonderful rest of your day, a wonderful week. Take care, stay safe, and thank you very much for joining.
Thank you very much, everyone.